Artificial intelligence is advancing at extraordinary speed, but behind every powerful AI system is physical hardware that eventually becomes outdated. In this video, we will explore the growing e-waste challenge created by obsolete AI chips and processors, and how reuse, repurposing, responsible recycling, and better lifecycle planning can help create a more sustainable future for AI. Artificial intelligence is transforming industries by improving automation, data analysis, scientific research, manufacturing, healthcare, transportation, and countless other fields. Behind every AI application, however, is powerful physical hardware that makes these technologies possible. Modern AI depends on specialized processors such as GPUs, AI accelerators, neural processing units, and other advanced chips designed to handle demanding computational workloads. These processors operate in data centers, research facilities, industrial systems, autonomous technologies, and edge computing environments around the world. As AI capabilities continue advancing, organizations regularly upgrade their infrastructure to improve performance, increase efficiency, and support increasingly complex models. While these upgrades drive innovation, they also create a growing number of obsolete processors, servers, and supporting equipment. Although AI is often viewed as software, its foundation is physical hardware that requires raw materials, energy, and manufacturing resources. As this infrastructure continues expanding, responsibly managing retired AI equipment becomes an increasingly important part of sustainable technology. AI hardware becomes outdated quickly because artificial intelligence evolves at an extraordinary pace. New models demand greater processing power, higher memory capacity, faster data transfer, and improved energy efficiency, encouraging organizations to replace existing hardware more frequently. Performance is only part of the reason. AI software frameworks, machine learning platforms, and development tools continually advance, often introducing features that older processors cannot fully support. As a result, hardware may remain functional, but no longer meet the requirements of modern applications. Heavy workloads also contribute to hardware aging. AI processors often operate continuously in high-performance environments where constant heat and intensive processing gradually reduce efficiency and reliability over time. It is important to recognize that obsolete does not always mean unusable. Many processors are retired simply because they no longer meet the needs of a particular organization, even though they may still provide value elsewhere. Understanding this distinction is essential for creating more sustainable AI hardware management strategies. The e-waste generated by AI extends well beyond individual processors. AI chips operate within complex systems that include servers, motherboards, storage devices, networking equipment, power supplies, and cooling infrastructure. When processors are upgraded, many of these supporting components may also require replacement. Large data centers can retire thousands of interconnected devices during major infrastructure upgrades. Entire servers, storage systems, networking equipment, and cooling components may become outdated alongside the processors they support. Although AI chips are physically small, producing them requires advanced manufacturing processes, specialized materials, and significant resources. Their environmental impact comes not only from their complexity, but also from the enormous scale of AI infrastructure worldwide. As AI adoption continues to grow, organizations must consider the complete life cycle of the hardware supporting these systems and ensure obsolete equipment is managed responsibly rather than simply discarded. The environmental impact of AI hardware begins long before equipment is retired. Manufacturing advanced processors requires raw materials, specialized production facilities, energy-intensive processes, transportation, installation, and ongoing cooling throughout their operational life. When organizations frequently replace hardware, new equipment must also be manufactured, increasing overall resource consumption. Extending the useful life of existing processors allows organizations to gain more value from the resources already invested in producing them. Improper disposal creates additional concerns because obsolete AI equipment contains metals and other valuable materials that may be recoverable through responsible recycling. Discarding this hardware without proper management wastes resources that could otherwise remain part of the manufacturing cycle. As AI infrastructure continues expanding across major data centers, research institutions, and technology companies, sustainable hardware management becomes just as important as the software innovations these systems support. AI processors are only one part of a much larger computing environment. High-performance AI systems also rely on servers, memory, storage, networking equipment, power supplies, and sophisticated cooling systems that keep hardware operating efficiently. When organizations upgrade processors, these supporting systems may also need to change. More powerful hardware may require improved cooling, additional power capacity, faster networking, or updated server configurations. As a result, hardware upgrades often affect far more equipment than a single processor. To manage this responsibly, organizations should evaluate their entire infrastructure rather than focusing only on individual chips. Comprehensive asset inventories help identify which components remain useful, which can be repaired or repurposed, and which have reached the end of their practical life. Looking at the complete system allows organizations to make smarter decisions about reuse, upgrades, and responsible recycling while reducing unnecessary electronic waste. One of the most important principles of sustainable AI hardware management is recognizing that obsolete does not always mean unusable. A processor may no longer meet the performance demands of cutting-edge AI models, yet still provide reliable performance for less demanding applications. Educational institutions, technical training programs, and research organizations often benefit from older AI hardware. Students can learn machine learning, programming, and high-performance computing without requiring the latest processors, while smaller research projects may perform well on equipment retired from commercial environments. Older processors may also continue supporting AI inference, software testing, and analytical workloads that require far less computing power than training large AI models. Reusing hardware in these situations extends its lifespan, delays disposal, and helps organizations gain more value from existing resources. Before retiring AI equipment, organizations should evaluate its performance, reliability, energy efficiency, and compatibility with potential secondary uses. When those factors align, older hardware can continue delivering meaningful value well beyond its original role. Repurposing expands on the idea of reuse by assigning older hardware to entirely different workloads. Instead of performing advanced AI training, retired processors may be used for software testing, employee training, development environments, or smaller analytical tasks. Many organizations discover that not every computing job requires the newest or most powerful hardware. Internal research projects, demonstrations, and development systems can often operate effectively using equipment that has already been replaced in production environments. Older processors may also support certain edge computing or AI inference applications, where processing requirements are lower. Matching hardware capabilities with appropriate workloads allows organizations to maximize the value of existing equipment while reducing unnecessary replacements. Repurposing should always be evaluated carefully. As hardware ages, energy efficiency, maintenance requirements, and reliability may eventually outweigh the benefits of continued use. When equipment no longer provides practical value, responsible recycling becomes the appropriate next step. Retiring AI hardware involves more than environmental responsibility. It also requires careful attention to information security. While processors themselves may store little data, the servers and systems surrounding them often contain valuable and sensitive information. AI infrastructure may include proprietary machine learning models, confidential research data, customer information, business analytics, system configurations, and network credentials. These assets must be properly managed before any equipment leaves an organization's control. Responsible decommissioning begins with identifying which devices contain data and determining what security measures are required. Storage devices, firmware, system configurations, and network settings should all be reviewed before equipment is reused, transferred, or recycled. Clear decommissioning procedures help organizations protect sensitive information while allowing suitable equipment to be reused or repurposed safely. Once security requirements have been addressed, hardware that has reached the end of its useful life can move through an appropriate recycling process. Responsible AI hardware management begins long before equipment becomes obsolete. Organizations can improve sustainability by considering the entire life cycle of their infrastructure during planning and procurement. Instead of replacing complete systems, targeted upgrades may allow existing equipment to remain productive. Additional memory, improved networking, upgraded cooling, or replacing only specific processors can often extend the life of an entire computing environment while reducing unnecessary waste. Maintaining accurate asset inventories also supports better decision-making. Recording hardware age, configuration, condition, maintenance history, and possible secondary uses helps organizations determine which equipment should remain in service, be reassigned, repurposed, or retired. Planning ahead transforms hardware retirement into an organized process rather than a reactive response. Functional equipment continues providing value whenever practical, while hardware that has reached the end of its useful life can move responsibly toward recycling. Even with careful maintenance and reuse, every AI system eventually reaches the end of its practical life. At that stage, responsible material recovery becomes an important part of sustainable technology management. AI infrastructure contains circuit boards, processors, servers, storage devices, power supplies, networking equipment, and other components made from valuable materials. These resources have already required significant investment in extraction, manufacturing, and transportation, making proper recovery an important environmental consideration. Before recycling, organizations should evaluate whether equipment or individual components can still support repairs or secondary applications. Once those opportunities have been exhausted, a structured retirement process helps separate reusable assets, address data security requirements, and prepare remaining equipment for responsible recycling. As AI adoption continues to expand, recovering materials from obsolete hardware will play an increasingly important role in reducing waste and conserving valuable resources throughout the technology lifecycle. The future of sustainable AI depends not only on how hardware is managed at the end of its life, but also on how it is designed from the beginning. Systems built with upgradability and modular components can extend their lifespan by allowing individual parts to be replaced instead of retiring entire systems. Energy efficiency is another important consideration. New processors often deliver greater performance while using less power, but organizations should evaluate whether replacing existing hardware provides enough long-term benefit to justify the environmental impact of manufacturing new equipment. Balancing efficiency with continued use can reduce unnecessary hardware turnover. Reliable cooling, routine maintenance, and system monitoring also help extend equipment life by reducing wear and identifying problems before they become serious. At the same time, ongoing software support is essential, as hardware that remains physically functional may become obsolete if it can no longer run modern AI applications. A sustainable AI strategy balances performance with repairability, upgradability, energy efficiency, reuse opportunities, and responsible end-of-life management. Cloud computing is changing how organizations access AI resources by allowing multiple users to share powerful computing infrastructure instead of maintaining separate systems. This approach can improve hardware utilization and reduce unnecessary duplication of equipment. Rather than purchasing specialized processors for occasional workloads, organizations can access shared resources when needed. Higher utilization helps maximize the value of installed hardware and may reduce the demand for additional infrastructure. However, cloud computing does not eliminate the hardware challenge. Large data centers still contain thousands of processors, servers, storage systems, networking equipment, power supplies, and cooling systems that will eventually require replacement. Because cloud providers manage hardware at such a large scale, they also have opportunities to develop organized systems for reassigning equipment, supporting secondary uses, and responsibly recycling hardware that has reached the end of its useful life. Sustainable cloud computing depends on managing the complete hardware lifecycle, from installation through final retirement. Artificial intelligence will continue advancing, creating new opportunities across nearly every industry. As organizations adopt more powerful hardware, they must also consider the environmental impact of the infrastructure supporting these technologies. Building a sustainable future begins with recognizing that AI has a physical footprint. Every processor, server, storage system, network device, and cooling system requires materials, energy, manufacturing, and ongoing maintenance throughout its lifecycle. Organizations can reduce waste by maintaining equipment, performing targeted upgrades, extending hardware life through reuse or repurposing, and assigning older systems to less demanding applications whenever practical. Before retiring equipment, they should also address data security requirements and evaluate opportunities for continued use. When hardware can no longer provide meaningful value, responsible recycling completes the life cycle. By combining innovation with thoughtful hardware management, organizations can continue advancing AI while reducing unnecessary electronic waste and conserving valuable resources. Artificial intelligence continues transforming industries and expanding what technology can accomplish. But every AI breakthrough depends on physical hardware that will eventually require responsible management. Many retired processors, servers, and computing systems still have value through reuse, repurposing, education, research, or other secondary applications. Extending the useful life of these systems helps organizations maximize the value of existing resources while reducing unnecessary waste. When hardware can no longer serve a practical purpose, responsible recycling provides the final step in sustainable AI infrastructure management. R2 recycling helps organizations manage obsolete AI processors, servers, and other end-of-life electronic equipment through responsible recycling solutions. By planning hardware life cycles carefully, protecting sensitive information during decommissioning, extending the life of usable equipment, and recycling responsibly, organizations can support both technological innovation and long-term environmental sustainability.